Helium was discovered on the Sun before it was ever found on Earth. In 1868, French astronomer Pierre Janssen aimed a spectroscope at the Sun during a solar eclipse in India and noticed a bright yellow line in the spectrum that didn't match any known element. 2 months later, English astronomer Joseph Norman Lockyer observed the same line independently. Lockyer named it Helium after Helios, the Greek god of the sun. Although scientists would later show that helium is the second most abundant element in the cosmos, it wasn't found on Earth for another 27 years. That detail says everything. Helium belongs to the universe more than it belongs to us. On Earth, it is a visitor, slowly leaking out of the ground, floating up through the atmosphere, and drifting back into space. We have been using it like it will always be there. It won't. Here's what most people don't know. We don't drill for helium the way we drill for oil. It comes up as a passenger inside natural gas. Almost all commercial helium supplies come from the production of natural gas. As the natural gas is pumped to the surface, it brings helium along with it. The helium can then be captured and stored separately. The helium itself got there the same way it got into the sun, through the behavior of atoms. Most of Earth's helium originates deep underground as a byproduct of radioactive decay, where elements such as uranium and thorium emit helium nuclei. When we drill for natural gas, we crack that jar open. The helium rides up with the gas, and once it's in the open air, because it is lighter than everything else in the atmosphere, it rises, clears the upper atmosphere, and leaves Earth entirely. Helium is considered a non-renewable resource because it is also light enough to escape Earth's gravity into space. There is no pipeline bringing it back. It joins the rest of the universe, where it was always more at home. Why that matters? Most people connect helium to balloons, but balloons are close to the least important thing it does. According to the USGS Mineral Commodity Summaries, helium was used for analytical, engineering, laboratory, and specialty gases at 22%, controlled atmospheres, fiber optics, and semiconductors at 17%, lifting gas at 17%, MRI machines at 15%, and aerospace at 9%. The MRI figure is the one that should stop you. Every hospital scanner that images your brain, your spine, your organs, runs on liquid helium. It keeps the scanner's superconducting magnets at temperatures so cold that electricity flows through them with almost zero resistance. Its incredibly low condensation point allows helium to remain liquid at near absolute zero, the lowest temperature theoretically possible, which paved the way for magnetic resonance imaging. And here is the hard constraint that engineers don't have a workaround for yet. Nothing substitutes for helium in cryogenic applications. If helium runs out, those machines stop working. How the US managed to sell it off? For most of the 20th century, the United States held the world's largest strategic helium reserve, a massive underground storage facility in Amarillo, Texas, filled since World War II. It was a genuine national asset. Then Congress decided to sell it. The Helium Privatization Act of 1996, signed by President Bill Clinton, required the U.S. government to sell off its supply by 2015 at below-market prices to pay off a debt the program had accumulated over decades. The stockpile that had taken generations to build was liquidated in less than 20 years. The United States remains the leading supplier of helium in the world, producing about 44% of total global production. But that position depends entirely on pulling helium up as a byproduct of natural gas drilling. Once a gas field is depleted, its helium is gone with it. U.S. helium import sources in recent years have included Canada at 47%, Qatar at 28%, and Algeria at 10%. When Qatar was blockaded by neighboring countries in 2017, a political dispute over diplomacy with nothing to do with science, hospitals and research labs on the other side of the planet scrambled for supply. A geopolitical argument in the Middle East nearly disrupted MRI machines in hospitals worldwide. That is how fragile the supply chain is. Is there a way out? There is, but it requires finding helium before it gets mixed into natural gas, rather than after. The USGS estimates 306 billion cubic feet of recoverable helium in the United States alone, representing about 150 years of supply at 2020 production levels. That number sounds comfortable, but it assumes efficient extraction, minimal waste, and steady natural gas production, none of which is guaranteed. What geologists have recently started finding is more interesting. For the first time, companies are exploring for helium as a primary target, rather than a byproduct of natural gas. In northern Minnesota, one project has drilled wells with helium concentrations of 8 to 10%, among the highest ever publicly reported. In East Africa, Tanzania's Rukwa Rift Basin holds what may be the world's largest known primary helium resource, independently estimated at 138 billion cubic feet. These deposits formed the same way all helium does: radioactive decay, millions of years, sealed rock. But they aren't tied to natural gas drilling at all. They can be extracted on their own terms. Closed-loop recycling systems are also becoming more common, with MRI machines increasingly built to recapture the helium they use rather than vent it. Helium is one of those resources that feels invisible until it is suddenly gone. It does not burn, it does not glow, and most of the time we barely notice it exists. Yet it quietly supports some of the most advanced technologies modern life depends on. From medical imaging and semiconductor manufacturing to space exploration and scientific research. The strange irony is that this element, first discovered by looking at the sun, may force us to think harder about how we use what we pull from the Earth. Helium took millions of years to accumulate beneath our feet. Once released, it slips past our atmosphere and disappears into space forever. We can waste it in moments, or we can treat it like what it truly is. Not just another commodity, but a finite piece of cosmic history we cannot replace.